Hello there, and welcome back to all of you in the room and online. The next session is looking at how today's radio networks can adapt to be an enabler of business growth. And so this is a slightly different topic insofar as it's not specifically 6G focused, but instead of that, we've got to look at the evolution path from 5G to 6G. I think in the past, we've talked a great deal about how innovations in the radio network can be a driver of efficiency, lowering that cost per bit, removing data potentially. But these days, many operators are horrified by the idea that after spending however many billions on 5G, or even 5G NSA, which is, I think some people would argue whether that's 5G or not. The idea that they're going to have to spend again on another generation of networks where maybe it's not clear how they recoup that investment is a little alarming. So the business case for making those upgrades needs to be addressed sooner rather than later. So there are two parallel questions here, really. One is, how do we upgrade? Because there's no doubt that over time, things simply need to be replaced in the network anyway. So there is going to be new equipment coming in, new functionality coming in. What that looks like, what that delivers is a really important question, and how we take it from where we are today. I once got lost in a small city in Turkey and was trying to find the way to the bus station, and the person trying to give me directions just absolutely froze, and then answered, "I wouldn't start from here if I were you." So I don't know if we have to undo everything in order to get to where we want to be. I think that would probably be incredibly dangerous, but that does mean that like it or not, we have a situation now where making those cases for investment, I think, is difficult, and making cases that you can save money is one piece of the puzzle. But my question to the panel is going to be, is that the only piece of the puzzle? Or can we find other ways to produce value and potentially business growth out of the capabilities in the radio networks moving forward from today? And to do this, I'm very fortunate that I've got three people with both some future-looking expertise, but also an understanding of where we are now. So that's Navid, the CEO of BubbleRAN, Gerhard SChoenthal, the COO of Virginia Diodes, and Ben Coffin, the Chief Global Business Manager for wireless research at NI. I'm going to give them an opportunity to introduce themselves, share some initial viewpoints and perspectives, and then we'll go from there in a much more of a conversational format. So again, if you're in the room, feel free to step in, challenge, question, add comments and suggestions if you like. I think everybody here is looking fairly brave and resilient, so I'm sure we can manage that. But otherwise, I'm looking forward to about an hour just before lunch to get us all energized, ready to digest properly. So with that, let me turn over first to Gerhard for some initial comments.
Sounds good. Yep. So just waiting on the slides here for a second. So I'm Gerhard. I'm from Virginia Diodes. We are leaders in millimeter wave and terahertz test and measurement equipment and components. We're located in the U.S. in the state of Virginia, which is about 2 hours southwest of Washington, D.C. About 120 employees and 3,000 square meters of manufacturing space all located there. We sell worldwide, and we're strategic channel partners with Keysight. So today we're here to talk about 6G, but I hear a lot of talk about whether there should be another G or not. I think regardless of whether there's another G or not, setting up another G for goals is a good thing to do, regardless of whether we get there. You know, I do think there will be another G, but regardless of whether there is another G, the wireless research will continue. And I think it's good to consider that there's going to be wireless elements that will become 6G that aren't necessarily just prescribed by what 3GPP calls 6G. And that includes backhaul, Wi-Fi wireless, NTN wireless, data server room type wireless. And I think, and sorry for the second matrix reference today, but I think we can agree that what we don't want to see in the greater matrix is a wire connected to the human. That last bit going to the human, you know, if we are plugged in somehow, has to be wireless. So, as I said in my introduction, VDI's focus and interest is in millimeter wave and sub-terahertz. And, you know, there's been quite a bit of grumbling about millimeter wave and 5G, that it didn't work as expected. You know, my view that we're in the part of the hype cycle that's past the trough of disillusionment and on the slope of enlightenment. But the fact is that we did try to run before we walked with millimeter wave and 5G. The technology, the semiconductors, the electronics, the systems were not ready for prime time in 2020. Now that's changing. It's maturing. I've talked to several experts in the industry that say that, and I think we can see that. But if we look at sub-terahertz going towards 2030, you know, I do not think that we will see sub-terahertz in a UE and a cell phone. I don't think that's the right way to go. But in that whole ecosystem and development, we need to crawl and then walk and then run. So coming back to 5G and what we can take away from 5G as we go into 6G, I'm going to point to what I think are two big success stories. And one is high density type events like American football matches. So for American football matches, all of the stadiums in the United States are highly deployed with millimeter wave radios. And at our recent championship, the Super Bowl 59 at the New Orleans Superdome, about 2/3 of the traffic was over the millimeter wave portion of the radio network. And in fact, Verizon told all of their customers to turn off Wi-Fi and use their 5G network exclusively, 2/3 of it being over millimeter wave. So that's case number one. Case number two, fixed wireless access has been a runaway success, particularly in the United States. The chart on the right from Verizon shows that. Most of that has been at sub 6 gigahertz today, C-band and bands like N77, but that's changing. We see that Verizon is looking for a deployment of millimeter wave, particularly to MDUs in 2025, so that they can return that lower band usage to truly mobile customers. So I think we need to lean in to success stories like this as we progress from 5G to 6G. And I'm looking forward to the conversation today. And please make sure to come get some t-shirts and hats before you leave. I can't take them with me.
Thanks very much, Gerhard. Ben, perhaps I can ask you to.
Absolutely. So, morning, everybody. So my name's Ben Coffin. I am I'm not that panel. Back up here. No, you're good. So I am the Global Business Manager for Wireless Research and Academia at NI. So I'll have a slightly different perspective because we are still very forward-looking into the research that needs to happen inside wireless communications. And so I work closely with academia to identify what what items really need to be researched and prototyped in these coming stages. And I think one of the interesting takeaways that I've come from, I was at the 6G workshop in Korea, and then subsequently went to a university event in the United States. And I hear a lot from the operators that their main care about is the business case, the revenue. When asked what should researchers be focusing on, the responses from some fairly senior network equipment manufacturers were, good question. We'll get back to you when we start making money again. And so I think we're in an interesting period of transition as we start looking at what ways can we actually deploy some of these technologies scalably, and what does it actually mean to do these deployments while still kind of keeping this perspective towards 6G. So I think one of the things I definitely echo from Gerhard is that we're definitely approaching, I think, one of the last Gs. I think that again, the looking towards 6G certainly helps us get a perspective of where we need to go, what functionality we need to get to. Pause a second before I go on too far, because I'm off book.
Yeah, sorry about this.
No, you're good. You're good.
I do apologize, Ben. I think this has gone AWOL.
Okay, no worries. I'll just ramble. So, I think one of the main things that I wanted to just circle around. I know I'm the first person to bring it up, but AI is going to be a really big deal for the networks. And so I think this is we've been hearing about AI nonstop the last couple of days, and looking at how we actually deploy AI in a way that is trustworthy. And I think we've heard from some of the earlier presentations today. I think that's key. We see the ways in which artificial intelligence is being applied at the RIC and the SMO today inside of 5G, and looking forward to how we actually utilize this to the best of its ability. I think there's a lot that has to happen in terms of identifying the right data sources in order to validate that we are training the right models. I think one of the things that we've found as we're rolling out AI in our own end-to-end research test beds is that there's a lot of things that if we train AI on a set of data, we can create blind spots very quickly. I think we're about to publish a paper with a university in the US that is all about essentially, even if you think you've got the exact right data that you fed this AI, if you throw a case at it that it's not prepared for, it will miss that completely. And even in spaces where you think, oh, okay, this is going to be well performing, high SNR, the places that the AI/ML should work correctly, if it didn't see that data correctly, then it doesn't deliver that. But thinking about how we roll out AI, I think that there's looking at how do we utilize the AI in the network today and roll that towards 6G, but then also what can the network do for the AI workloads? So I got a couple of quick anecdotes on what I was just thinking as I was coming up with ideas for this panel of, where I see places where there's additional monetization capability. And so this human to machine type thing, I mean, this is happening today. I just moved from Austin, Texas in the US, big metropolitan space, to basically right where the anode is on the Virginia Diodes logo. So I'm in a fairly rural area. I'm still in a city, but not great connectivity. And I use the ChatGPT voice call to talk to ChatGPT as I'm driving around the city. And I'm already implementing human to machine. I'm designing things with ChatGPT that I'm going to 3D print on my 3D printer at home. And that's all happening right now. And I don't have the cell service that supports that voice call to ChatGPT as I'm driving around the town that I live in. And so even the 5G coverage today is not delivering on an app that I'm going to be using on my phone all the time. I think there's also, we think about the operators. How are we going to get you to spend $5 more a month on your phone bill, right? I actually just upped my phone bill by $10 a month. $5 of that was because Verizon gave me a free iPad, but the other $5 was because I got the cellular modem in my smartwatch. And it's in all this discussion of hyperconnectivity. one of the things that I think I find myself, and I know a lot of folks find themselves wanting to do, is unplugging from time to time. And the reason I added that $5 a month is so that I can leave my phone at my house and go for a hike and still make a phone call, talk to my brother who lives on the other side of the country. And that was worth $5 to me. And so I'm thinking about those use cases where, okay, what services can the operators actually provide now that will encourage the consumer to actually spend a little bit more. So those are the things that we're thinking about going into this discussion.
Great. Thanks very much, Ben. And Navid, over to you.
Thanks for the invitation here. I'm happy to be part of this panel. So I'm Navid, CEO of BubbleRAN. So BubbleRAN is a startup company actually founded in France here at Eurecom, essentially. So we started from R&D here since 2021. And we are a kind of unconventional telecom company. We are looking into some overlooking topics. For instance, automation was one of the topics we have been starting to look in 2014 already. Was back then the NFV era with OpenStack, and then later Cloud Native came and took over. Another topic we are looking is network intelligence. Obviously, you touched upon AI and the role of AI into the whole automation, how this could be actually combined together. Last but not least, we truly believe in open ecosystem. So one of the 6G pillars that we see, it's emerging and it is already in place, and some of the big players such as Ericsson, they're already leveraging this, is to kind of get inspired by own ecosystem, a smartphone ecosystem, which we had these SDKs that were open, providing developers an opportunity to contribute to the phone ecosystem. So now Ericsson is also thinking towards that, and I think this open ecosystem, leveraging open source, bringing the developers is also one of the things we also enable to our scale. So we have a range of products that actually provide this capability of automation, intelligence, and system. And then in terms of this panel, I think you're going to have more questions, but if I want to say a very big introductory, I think there are already a lot of big players such as Amazon. They're already looking into migration legacy towards forward-looking architecture such as ORAN, for instance. So I would say this capitalizing on existing infrastructure, looking into monetization strategy, business growth is already ongoing.
Great, thank you. And before we carry on, I do have questions. I think sort of picking up on some of the things that you're saying, but I want to make sure that as we're going through, if you have things to add, just try and catch my eye. I'll do my best to keep it on as we go. So, I mean, to summarize then, there seem to be a number of different avenues that we're talking about here where we are making progress already, whether that's in the open environment and ecosystem, in terms of intelligence in the network, and also at millimeter wave. Something that strikes me across all of those is that in some ways they are all unconventional. We're looking at things which maybe 10 years ago weren't particularly associated with telecoms. So, for example, the idea of using a signal to provide fixed wireless wasn't unknown, but it was very rare. The open networks and particularly the AI. So again, it just makes me wonder whether you see a parallel migration path actually within either within the major telcos or Navid, in your case, you are pursuing a sort of slightly different route. So in terms of your clients, what's the industry going to look like when it grows up, I guess, is the summary here. But Navid, maybe I can get you to start and just explain a little bit more about, who your clients are and how you relate to, if you like, those national scale telcos.
The majority of our customers are coming R&D today, like up to 70%. So I cannot really talk about the big industry. We have 30% of the industrial partner. But what I'm seeing is that now we are in the exploration phase. In a sense that all of, whether it is extremely forward-looking architectures like a terahertz, for instance, or even more immediate evolution, which, for instance, O-RAN could be an enabler. So when it comes to what we see as the customers, they are looking at the very beginning, I see exploration. I see how they can monetize these new innovations, for instance, how they can monetize O-RAN or AI in their existing infrastructure. How can they extend the existing infrastructure with some new entities elements, right? That combines the current with the modern network. So it's more like a hybrid type of networking, converging maybe different wireless access technologies, terahertz, Wi-Fi, 5G, FR1, FR2, and so forth. So I would say the very first one is to leverage AI. I see that there are a lot of customers are asking for how to leverage the AI. So one example, for instance, that is very much obvious is the network assistant. This could be an entity that, whether it's private 5G or public 5G, could be useful to assist the operators or network optimization or network operation, even scheduling a technician to go on site. That still is a case for operators. And when it comes to even private 5G, this is still a useful case to be able to simplify the network operation, even at a very, very small.
Great, thank you. Yeah.
Yeah, so I'm going to pick up on something you said, which and talk about one of my favorite topics, which is FWA. And you were saying that it's something new, but it's something that actually that was old that's new again. There's been companies out there for forever called WISPs, wireless internet service providers, that have provided wireless service to customers probably going back to the 90s. What made it different in 5G? Well, the 5G network was set up to be able to handle the CPEs so that it actually worked and could be done at scale for the first time. And so, that's something that is seemingly new, but it's been around for a long time. I go back to my childhood, which was in the 1970s. I remember hearing about car phones in the 1970s. Well, those car phones weren't on cellular networks. They were on some proprietary network before that, but they really didn't take off until you got legitimate cellular networks, and then everybody could have their bag phone, and then everybody had their brick phone, and everybody had their regular phone. And so, timing is everything sometimes. There were smartphones before the iPhone, but the iPhone came along and everything was in the right place at the right time to make it successful. I actually had a Newton back in 1992, and it was the precursor to the iPhone. Wasn't successful because everything wasn't ready for it. And so I think instances where you can take a technology that is maybe was thought of in the past and then can be applied to a network, and with something like fixed wireless access, and I don't think that fixed wireless access is the end all for broadband. Where you have fiber, you should use fiber and put a high capacity radio at the end of the fiber, whether that's Wi-Fi or something else. It's a complement to it. And it's for those people that are either unserved, underserved, or just pissed off at the cable company, right? And so selling, whether it's hundreds of thousands of CPEs in the United States or millions to tens of millions to a billion CPEs in the subcontinent of India, I think those are things that are practical business considerations that can sell product and put money on the bottom line.
Yeah, I'll pick up on the technologies that that maybe the timing isn't right or anything like that. I think one of those that comes to mind for me is full duplex. I think obviously I work with universities, and so full duplex is the research project. You go to any wireless research lab, you're going to find one person at least playing with full duplex, trying to figure out how do we increase spectral efficiency that way. And so I still again, just listening to the conversations at 3GPP a couple weeks ago, the full duplex pieces still aren't completely adopted in a way that gives us the spectral efficiency that we want. And this is still something, as we talk about coexisting 5G and 6G spectrum, full duplex comes right back into the picture. So I think you're exactly right on that. Like there are technologies that we have had in this wireless ecosystem that just need to find that right sort of connection that aren't locked into necessarily the 3GPP cycle or a particular standard. I mean, I think to kind of jump over then to the openness side of things, I mean, I believe that we need to really embrace openness even more so in the network. And that is both in the Open RAN type direction of being able to open up the APIs and the interfaces, but also open source and being able to extend, look at what we can actually enable by having a clear understanding. I mean, we're talking about students are afraid to get into telecom because computer science is hard, and we get into these cellular stacks and they're very complex. I think if we start, and I'll give a shameless plug for Open Air Interface out of Eurocom that is doing exactly this, enabling an open source stack that can be used for students to learn how these things work. I mean, part of that is where we're going to get innovation and how we get actually, pulling out what else the network is capable of. And so I think leaning in on the openness side of things will really give us more opportunity to be able to extend the functionality of the network, enable new services, and really play around with what's possible. So I think we need to push forward in the openness. And I know that, again, that kind of starts to get into this, like, hey, we want to have a very softwareized view of the network. We want to be able to deploy features at a cadence that maybe isn't on the 10-year cadence. I think if we look at what AT&T is talking about, where they've really pushed into this. What if we did CI/CD for the entire standards? I mean, right? They're talking about, let's break off of this 10-year cycle. They don't want to wait to monetize a feature that could, that they could roll out now as opposed to waiting 10 years. And so I think it's a very radical idea. I think it very much changes how we approach things. And the Open RAN Alliance has created some interfaces to move things a little faster, but they're talking about taking that a step further. And so I think that there's some interesting, 6G seems like it's going to be an evolution, but there is some revolutionary things that I think are still on the table for us to explore.
Yeah, and I'd actually like to pick up on that because you mentioned there obviously the softwareization, the openness. Now I've heard from the Department of Defense that they're all in favor of openness because it gives more opportunity to have visibility into what's happening in different parts of the network. But it also opens up an increasing number potentially of APIs. And we saw from Mobile World Congress this year that the Open Gateway program, for example, has been, it was launched a couple of years ago, and they actually had instances now of customers using those APIs actually in practice and generating revenues for the telco. Now, not a huge amount, but in any given use case, but some of these were proper business models rather than, as we say, use cases. Things like, for example, having somebody driving a car remotely to where a customer wants to hire it. So you get your home delivery of your hire car thanks to a remote driver. using it in part those APIs.
How about
And-
somebody to take my car home for me when I've had too much to drink?
That actually sounds like a great business model. My former father-in-law was Irish, and he did complain about the drink driving laws, because if you're too drunk to walk, you have to drive. And I'm very glad that I think he was joking. But the point is that there are these kinds of use cases that are emerging thanks to changes in technology direction. And you know, I'm curious to see whether there are things that you think may be being left on the table, actually, as we're moving through from 5G forwards. We've talked a little bit, for example, about AI over the last couple of days. And I think Nancy Alonistioti yesterday was follow the money. That's in AI. Let's make a 6G that can enable the big players to do what they need to do better. And I was just trying to imagine what that might look like. Are we talking about here simply guaranteed quality of service, maybe, which sounds nice, but maybe not a huge revenue enabler? We're thinking GPUs. I mean, have you had any conversations sort of with clients around these kinds of areas where you think that might lead?
Well, I haven't had necessarily conversations, but I saw a good demo actually from Qualcomm, and I can't remember if it was MWC24 or more recently, where they were actually using AI as active channel sounding to determine where dead spots were. And this was for a trial at their campus in Southern California. But to me, large language models, they're great. They can help you complete a sentence and, when you're writing your email and that type of stuff. Love it. But are there really practical uses of AI to improve the engineering of the product that we're putting out to customers so that they can go live their lives in a better way? And I think those types of things are great. You may be using AI to find Ben's dead spots in Roanoke or Botetourt County or something like that. It would be a good use of AI where, Verizon, what was it, back in the 90s? Can you hear me now? Can you hear me now? Having AI can do can you hear me now and actually solve it. That seems like a good use of AI.
I think there's also a lot of, so part of where we're having conversations with our customers is around the data collection piece, right? And I think part of the challenge as we're having these conversations about where do we apply AI best and what's the right way to take, because frankly, we could throw AI at a lot of things in the network. I think that's a big part of the challenge here. But one of the things that I hear a lot from my clients is, the researchers, they don't have the data sets that the operators have, right? And so step number one is getting data that we can actually evaluate whether or not AI is performant or not. Because I think, part of what we've been coming away with is that even if we get an AI thrown at an application, it might look like it's working, but then you actually really dig into the depths of it, and it's missing big chunks. And so I think as we think about how we expose the right data interfaces, again, this is where I think openness becomes very valuable in that we can tap the network more effectively to source data for training AI in different aspects, and figuring out then what can we apply from there. So I think the data collection piece of this is kind of a precursor before we can really say how do we best utilize the AI, because I think we need to make sure that we're all playing on the same terms with the data necessary to use it.
And Navid, maybe I can ask you for a reality check on this, because your clients aren't necessarily the national scale people that have to spend billions, but are looking for something which is very much up to date. So does that ring true for you? Ben was saying.
Definitely say that data is very important essentially understanding the network. But I want to give another perspective here, and that perspective is that there are two new requirements that are emerging. One is that as opposed to legacy network, that the networks are already in place and they are planned for a long-term usage, Navid suddenly looking into the short-term, like the network that are created on the spot for a short period of time, and you need to manage their life cycle, provide the service, and then, so it is more like a self-service pattern. So that requires quite an agility in being able to deploy a small network without too much overhead, without too much cost involved, so that that could become like a benefit. That is one side of the things. Now, that network being short life network, another property of that network is that that network is shared potentially with the public. You have a public network that is already running, but you want to share that network with, for instance, part of the private network that is actually happening for a short period of time. So not only you are sharing, multiple stakeholders sharing the same network, but at the same time you want to manage the life cycle of these smaller networks that are happening. It could be even a network that I create for myself at home for my friends that they are coming. I'm not using Wi-Fi necessarily, right? So that goes to the concept of network slicing, right? That goes to the concept of how the network is managed. It is self-service. From my phone, I can create my own private 5G net. Doesn't necessarily means mining, hospitals, right? So AI here is instrumental in assisting someone that doesn't know 5G be able to create such a network. It could be also from the municipality, an event happening, want to create that network, and then if you go to the military application or even civil, like public safety type of application, these are kind of event-driven networks, right? Want them to be self-service. But these are where AI could really help.
Maybe to pick up on that too, and I think in terms of also technologies that maybe didn't see the light at the right times, but with more of these, sort of ad hoc private networks being stood up, I think one of the questions that ultimately get back to is spectrum, right? And what spectrum do we actually utilize for this? And CBRS might be one way to do it. I also think that some of the listen before talk kind of LAA type things that we saw in the 4G timeframe really still could be applicable in bringing these private networks up in unlicensed bands. And so that's something that, again, we can implement that on 5G today. I mean, there's a handful of projects that I've seen implementing that functionality on open source stacks today to show, hey, we can coexist 5G in the unlicensed bands, no problem. And so I think being able to look back and at some of these technologies and say, all right, if we're going to do the private network thing, where does it go? And I mean, we have tools in the toolbox to enable that.
This kind of picks up from a conversation yesterday. I think that Izzo was pointing out that it's becoming easier and easier to create these local networks, and the challenge really is the engineering element. So if we're looking at a situation where we're standing up temporary networks, more flexible networks, that kind of thing, then presumably that's going to create all kinds of opportunities, but it's also going to require maybe some very different ways to manage that engineering. So, we can be looking at these technologies to, for example, manage the radio better in an unstable environment, let's call it, or a changeable one, and then actually sort of produce these services to market, which would be very different from what we've seen before. I mean, is that a direction that Navid, you see actually being taken at the moment?
Let me say a word about the vision of BubbleRAN, and that is we are living in limitless connectivity bubbles. Right? term bubble actually comes. That is why I think automation, intelligence, and open ecosystem, automation to be able to quickly create this network of connectivity at the level of personal area network, right? It doesn't mean it's for tomorrow. The time to market is very important. But one thing I really want to add to the time to market is the ecosystem. Like, I believe that if the right ecosystem is in place, we could push a little bit the boundaries of the time. Like, we could stretch it a little bit by giving the ecosystem to the customer. They will adopt it if the ecosystem is properly designed. So that would be my 2 cents here.
If I never had to set up another Wi-Fi system in my life again, I'd be really, really happy. And, you know, being a network coming in place that it just is a box and it arrives and it sets itself up by AI or some other mechanism, and it's known quality of service, that would be fantastic. I mean, Ben and I were talking the other day. Outside of my home Wi-Fi and my business Wi-Fi, wherever it is, I give the Wi-Fi about half a chance to work before I'm straight over onto my hotspot, because I know that that's going to work for me in most instances. Even here, I was able to do it. So maybe not in every seat, but in some places. And so, yeah, being able to set up, Wi-Fi has been great. I bought a Wi-Fi hotspot in, I think it was 1998, one of the original airport extremes, right? Because I bought one of their iBooks, and I was like, oh, this is great. I can go sit on my couch instead of having to be connected to the Ethernet. Fantastic. But, you know, then I couldn't go out in public because there weren't any other Wi-Fi spots. But and so Wi-Fi's has been beneficial, but the quality of service in a lot of instances is suspect. And so I think whether it's 5G or 6G, having networks that can be set up in a private, ad hoc, semi-public, whatever word you want to associate it with it, fashion, so that people come in, they're like, oh, it works.
Well, I think one of the things that we have heard from the operators and the network equipment providers is that 6G needs to be simpler. I heard that over and over at the 6G workshop was we need a simpler 6G. Now, some of that came from NSA was just a huge pain and everyone just wants to go straight to SA. But also, I mean, look at how complex the network has become. I mean, we've been talking about all these applications the last couple of days that we want to enable 6G to be able to do. I mean, we're taking an already very complex standard and a very complex network and saying we need to add, I mean, the graphs that have the sort of like 4G, what 4G functionality have, and then 5G expands, and then 6G is even bigger than that. I mean, I think we have to be realistic in what simplicity means, because I think if we're goal, one of the goals for 6G is ubiquitous coverage. Ubiquitous coverage can come from simplified ad hoc small networks. And I think that this is, again, and I'll give my plug for open source, because I'm talking to students and researchers who are trying to set these things up, who are trying to build these things so that they can figure out how they can make a contribution to telecom that will make an impact, right? And one of the pieces that I see is that this is, again, a role for LLMs. We think about, like, when I was in school, we were learning assembly, and I don't think anybody's really programming with a lot of assembly. I mean, if you're programming with a lot of assembly, I apologize, but I mean, students are learning Python, and that's what they want to engage with, and that's what they want to connect with. And so, part of the current ecosystem that supports that is the X apps and the R apps. I can't tell you how many of these grad students that I'm talking to that are they no longer care about the physical layer. They don't want to do physical layer research anymore. You know, the PHY is commoditized. They want to do X apps and R apps because they're comfortable in these environments where they can build these applications. And so one of the things that I keep going back to and thinking about is if we do continue to open up the network, if we can make it easier to, if we can simplify it, can we also add an abstraction layer around that really lets people interact with it? You know, we heard the discussion about intent-based networks and like where can we continue to do that? Because if we want these small private networks that we can set up ad hoc, it has to be easier than the current state of the network.
Thanks. I mean, I guess that the implication of that then is something quite profound. I mean, if we're looking at both simplicity and flexibility, then there is maybe a very different kind of business opportunity for the major telcos. A couple of years ago, purely anecdotally, I was chatting to somebody from DT, and at that point they were trying to understand the business case for 6G, and rather than it coming from the technology side, actually, there were a number of people looking at that from the financials. Could they use whatever 6G came to be as a way to get rid of all of the legacy systems that they had to keep in operation? And if they could do that, then at a stroke that would justify however many billions they had to spend on new infrastructure and new architecture. Now, I haven't heard anything more about that, so I don't know how realistic they found that to be. But when you talk about that simplicity, that flexibility, I can understand that there is actually as well as just to prevent the tearing out of the hair, a very strong business case for that. And so I wonder, maybe just putting this out here as speculation for you and for the audience, is actually a real opportunity if we're looking at business growth in 6G, just to get rid of some of this old baggage.
Well, I think that's 100% the case. I mean, you look at operators like AT&T in the United States, they want to sunset their DSL network, their wireline network. And how are they, I'm going to go back to my favorite topic, how are they doing that? They're doing that by bringing in FWA to places that would have been served by DSL because they can't get the fiber there quick enough, right? I mean, the fiber, again, I'm going to say fiber is great. It is the end all end all. If you can get fiber to your house or to your car or whatever it is, that's fantastic. But if you can't get that and your legacy system needs to be sunsetted, then wireless is a good complement. And why not use it? We can use it now. So yes, I think that there are these business cases. There are big operators that want to get rid of the baggage that they've had, and maybe increasingly so. And maybe that's increasingly a subject we should be talking about, is how they do that, how they strip off these legacy systems quicker.
I think too, in looking at the legacy systems, I mean, one of the things we've heard about 6G is that it really needs to be a sustainable G, right? I think that now that sustainability comes from a variety of factors, but the energy efficiency piece of that, I think, is a huge part of it. I mean, that's something that we've been looking into, enabling, you know, how you actually measure the energy efficiency of a network and profile this. But if you look at, I mean, 5G is a very energy efficient standard. We were talking about this the other day. 4G, 3G, and 2G are consuming far more energy than the 5G network. And so, you know, we keep hearing about how do we, you know, the operators want to optimize. AT&T's paying, sorry, we keep talking about AT&T, but they've got $1 billion power bill every year, and they're trying to drive that down. The OpEx is just, it's too high. And if they're not adding additional services that are going to get revenue on top, we're going to go for the OpEx. And so I think where we look at the potential of 6G is if it can replace some of these legacy functionalities with a more energy efficient standard, that in turn is a cost savings. And so it's not only you know, getting rid of this because it's a mess, but also it drives towards this vision of how do we make sure that the ICT industry is not consuming and burning all of this energy, especially because we're going to throw more AI at the network, and that's going to burn energy. So we have to make up for that somewhere.
So I mean, we're sort of tending in a direction, and it almost sounds as though BubbleRAN is kind of the pace setter here, insofar as presumably you're not carrying around sort of legacy systems from 3G and so forth.
No.
So if we're talking about, using the networks as an opportunity for revenue growth, I mean, it's clear that there are capacities that we can lose. I'm just wondering where you see opportunities, for example, in terms of the creation of new services. You've touched a bit on the use of networks for AI, and particularly for AI within the networks. But is that a service creation thing, or is that more an optimization? I mean, if you're a CFO, then you love optimization, and it may be a lot harder to make a case for, trust me, bro, this is going to make us millions. So, do you see any places where people are making those cases, rather than necessarily use cases, but actual business cases where there are opportunities for that revenue growth?
I think I can refer to Ericsson here. So I said at the beginning that they are introducing this ecosystem of RApps. It is called Ericsson Intelligent Automation Platform, EIAP. So I think they are not also inventing a new things. They are just reproducing what happened in Android and iOS type of operating system. They are bringing, it is called in the jargon of the marketing or business, is called two-sided market. Essentially, they are bringing developers into the ecosystem. So what does it mean? So you have a central portal. If you go for App Store or Android Play Store, right? What do you have? You have a portal, you have a users, us, you have a developers on the other side. The more developers you have, the more use case you create. The more use case you have, the more users they're buying, right? So these are apps. Tomorrow you could call AI agents, but we were saying LLMs, but they could be anything, right? So now the point being, again, I come back to open ecosystem. All of this is open ecosystem, including open source, right? Open source is, in my opinion, tiny part of it, not the whole part of it, right? So if we bring the developers into the network domain, creating applications or apps or agents or whatever you want to name it, enriching the network with majority of the use case for private 5G, for public 5G, for personal 5G, whatever you get, bubble 5G, right? Then I think that will create more dynamics for the network. That is how I see the business growth could actually come, not from the vendors, not come from the operators, but from.
Yeah, I was going to say, I'm an engineer. I'm of the mind frame, build it and they will come, right? And I know that that's not very popular sometimes, but I think, you throw enough technologies out there and somebody's going to latch onto it. And that's, our jobs as engineers is to come up with those new ideas, build them, and see what takes.
Well, and I think as well, in terms of throwing out crazy ideas, I think we talk about trying to monetize the verticals, right? And I think that this is a huge desire for the operators, but I have heard historically from the operators, it's really hard to get the verticals engaged. I mean, we talk about offering service to the verticals, but what, are we offering them a service that they want? And I think there's, I'll nerd out for a second. I think the smart agriculture thing is incredibly cool. I think there's a lot of exciting stuff around smart agriculture. And I think if we really take an end user focus of offering a service in something like smart agriculture, the end user are the farmers, right? So what is it that the farmers are struggling with? There's a great documentary series called Carbon Cowboys. I highly recommend, if you care about cattle and restorative agriculture techniques, check it out. It's a great watch. But these ranchers that have developed a technique that essentially, rebuilds their grasslands and creates more water retentive soil and is reducing the overhead for them to run these farms. And this is an agricultural practice that is available. Let's go get John Deere and let's implement these on the herding robots that they're building and put those on a network, and that's a service. Like, that's how you go sell a service to these verticals, where you can actually go in and say, hey, not only, like, if we go in and say, hey, we'll connect your farm, the farmers, they don't want to deal with another robot. I mean, there's all the policies around tractors and the complexity of machinery right now. They don't want that. But if you can come to them and say, hey, we can not only, essentially heal your farmland, make it more sustainable, reduce, bring back grasses that will feed your cattle and reduce your overhead. That's a service. So I think that there's and obviously I talk to a lot of these researchers that are doing fun and crazy things, but I think I would encourage industry to go find the researchers that are in these vertical spaces and see what proof of concepts can we go put together that actually demonstrate the value of adding the network to these unconnected places.
I just want to say one word: multidisciplinary. That is what you try to say.
Exactly. Yeah, the multidisciplinary thing. I mean, this is last couple weeks ago at UT Austin for their industry day. The network equipment manufacturers are talking about, hey, well, we need to find the business cases, we need to find the revenue, we need to make sure that 6G is delivering TCO, and the professors there, all in wireless research, were like, we've got a world-class business school right around the corner. Like, let's go talk to them. Like, let's get them involved. I mean, it's got to be multidisciplinary.
That's the point.
Yeah. So I really like that idea. There is a book that talks about some of the cities over time that have boomed and been hubs of creativity, and whether that's classical Athens, medieval Florence, whatever. And it is very much that interdisciplinary activity. I'm kind of curious though, because I get the impression that actually within the telecoms world itself, it's becoming increasingly interdisciplinary, in the sense that, maybe 20 years ago, you had to know about network engineering, and then you had to know about sort of figuring out the cloud and IT. Now AI is coming in, and okay, those are all disciplines within, let's say, the technology realm, but it makes me wonder whether there are now opportunities where for example, we can look at the pace of change in software or AI, so on, to actually change some of our approaches in the physical networking space, and maybe take more of I hesitate to say a platform approach, but should we be maybe looking at building things differently, so that then if we do have new capabilities and concepts coming on board, then it becomes more easy to implement them without, for example, a physical network upgrade.
Not sure if I understood the question completely. So platform as a service, like similar to what happens to the cloud, or what kind of platform you're thinking?
Yeah, okay, fair enough. My thinking wasn't very clear on that. I guess I'm thinking, are there ways that we can change how the physical network is engineered? And whether there's opportunities to build in, for example, different forms of resilience or so on, which might have, let's say, a 10 or 15 year lifespan, when we know that, for example, the radio capabilities are going to get upgraded every year and a half, or whatever it may be, and that we may have AI implementations that bring new capabilities out to those places.
So I think the thought there is, replace more and more of the network with the computer, right? And
Software-based.
the software-based. Eventually, when you get to the antenna, you've got to have a piece of hardware. But I think that I'm not an expert on this, but there is evolution in consolidating the amount of hardware that you've got to have at the end. So that's simpler. I know that in some of the millimeter wave call them base stations, antennas for lack of a better word. There's just an Ethernet coming into them, and they're smaller cells, right? But you're not talking about several pieces of equipment sitting in a room size type place. And so I think all of the, let's make the network a computer, let's have it optimized by software is great. But somewhere at the bitter end, you've got to have a piece of hardware that's not a computer.
It sounds like we need software-defined radios, which I'm just gonna, it's a shameless plug for our software-defined radios. You can find out at our demonstration booth.
Thanks, Ben.
Appreciate the setup. No, I think that you're exactly right. Like there's all, I keep, the ORAN discussions have been really fascinating in figuring out, hey, okay, which lower layer splits do we care about? Which ones do we want to enable? And it's, there's everything from, we were all on split 8, and now that it's 7.2, and now I'm seeing things go back to split 8. And now it's like, can we even go further? I mean, let's just put an ADC and an antenna at the end, and everything's and it's an Ethernet port, and that's it, right? Like we need to converge. If we are going to converge on software, we do have to converge on a radio architecture that supports all of this ecosystem. And I'm not totally convinced that 256 MIMO base stations is the way to do that. I think something that is more distributed, smaller scale, is the right approach. I think that's part of it. One other thing that I'll touch on, and kind of the thing you were talking about the multidisciplinary and how complex telecom is getting. This is something that we see in the teaching side of engineering, where students are really intimidated by coming into to any of these telecom disciplines because of they have to know everything, and it's a real workforce development problem. And we hear this from a lot of our customers on the industry side saying, hey, we can't hire telecom engineers. They're really difficult to get out the door. And so I think what we have to start figuring out is how do we teach this more practically in throughout the engineering education, that while scoping it down, I think, and part of that is we have to have a standard that people can build around, right? If it takes 15 years to get a PhD out the door in order to work on this stuff, I mean, that's a long cycle for talent, right? What can we be implementing in terms of the architecture that can get students in and plugging into the network immediately?
Got to do that downloading that was in the previous Matrix clip.
Yeah, there you go. Exactly.
Maybe there's some questions out there in the audience, Alex.
Yeah, that's certainly. Thank you. Well spotted. I'll bring you my microphone. We're currently using the lot.
Hi there, Dean Bubbly. I just want to follow up on that last point about how you deal with multidisciplinary in terms of training and skills and architecture. And the usual answer elsewhere in other parts of the tech industry is modularity and APIs. Yeah, so for example, one of the challenges I see with cellular at the moment is the interdependency between, for example, the RAN and the core and the services layers. Yeah, the idea that if you want to have a voice call, you need an IMS and you need a SIM card for authentication. There shouldn't be those dependencies. We should have any authentication, any application layer. Within the RAN, you can break it down into the R apps or X apps or sort of other functional elements. And then you don't need to train someone to expect the voice call to be using CSCF or whatever it is in an IMS and blah, 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 blah. It's just an application server. And you can turn it around the other way. You don't need the core. You could have a naked radio driven by a Wi-Fi controller if you wanted to, or a satellite, whatever satellites use for their controllers. So, it's that sort of interdependency, I think, is part of the problem of, that it's all knitted together.
Agreed.
Well, this may be something potentially where Navid's able to comment, because it sounds as though you're going along somewhere along those lines with BubbleRAN.
Yeah. I go back to what you just said. I think we see that we need more skilled people, at least at the level of PhD. More than 70% of our staff are all PhDs. The telecom also, they get involved into AI, not necessarily towards verticals. That is, I think, yet another level. But if we see, at least I'm also teaching 5G courses at Eurocom, we see that the master level is not enough at all for students to be operational in this space, right? So when we see the PhD students, when they reach to the final stages, now they can actually understand and do something tangible, right? So I would say the system is complex. I don't think in 6G we can reduce the complexity of the radio, but we could abstract it, as I think you said. We can abstract it quite good so that LLMs intent-driven could actually work. The system naturally will be more complex, right? Which means that we need more skillful people to be able to understand the system and design it and to work it. So I don't think there is any way out of this. Now, when it comes to the vertical, I think that needs to have specialists to essentially factor the requirement, the needs, the solution that is needed, like a solution architect that actually comes from agriculture, works with the telecom people, build a solution jointly together, right? I don't think we can compress all of this skill into one person anymore.
You know, there's other engineering type tracks or professions that have very successfully done this type of aggregation. And I'll point to where I started out, which is the semiconductor industry, right? So you consider a corporation like Intel. When I was hired by Intel, they were actually going to go into their fab, their development fab. You could not be an electrical engineer. You needed to be a chemist, a material scientist, a physicist, etc. Right? And they successfully, semiconductor industry, Intel is an example, not right now, but they successfully aggregated all of these disciplines to put out what was probably one of the best of mankind's best efforts in creating the whole semiconductor industry. So it's possible to mash these different talents together.
Great, thank you. Before we wrap up, I am going to just check in the audience whether you have any more sort of thoughts or contributions that you want to add, because we are getting close to lunchtime. But clearly there's room for some food for thought before food for everybody else. If not, then what I would like to do is just check with the panelists whether I'm summarizing what we've talked about here correct. It seems as though from the discussions, actually looking at something that's simplified, software driven, has the opportunities through creating those developer communities, whether that's around the X apps, the R apps, actually could be one of the greatest strengths of the evolution of telecoms, whether we call that 6G or whatever else. I think strikingly, other than in terms of particular use cases, we've not actually even mentioned much about spectrum, which is probably going to be very exciting for the telcos in the audience if they don't have to buy more. But is that correct? Am I missing some tricks here in what we should be thinking of?
Well, I'll hit on spectrum since you mentioned it. And so what I say with spectrum is follow the physics, right? And so let's talk about backhaul for a second. If you go to one of the high-end, if you want to do backhaul, the highest end backhaul, you go to one of the high-end E-band radios, E-band being 71 to 76 gigahertz, 81 to 86 gigahertz. You can get about 25 gigabits per second out of that E-band radio for backhaul. If you need to do backhaul at hundreds of gigabits per second, terabit per second, or tens of terabits per second, well, you need much more bandwidth than that. And where do you find that bandwidth? Well, it's not below 6 gigahertz. It's above 100 gigahertz. And so for certain type applications within this whole 6G ecosystem, if we're going to be transporting a lot of AI data back and forth in the aggregate, there are opportunities for new spectrum that are not maybe central to the whole 6G premise, but are necessarily needed.
Brilliant. Thank you. That's another mic drop moment there, isn't it? No, thank you very much for that. I think it's been a really useful experiment and a useful insight into the kinds of conversations that you're having and exploring. And I'd like to thank you in the audience as well for being here and enjoying this. Now we're going to take a break for lunch. When we come back, then we'll be looking a little bit more at AI native in the next G, and then finishing up on resilience and security, things which we probably should have been talking about a good deal more here. But in the meantime, thanks to Ben, Gerhard, and Navid. Thank you.